Question 11. What changes sodium hydroxide pellets to liquid? Right. Now, one thing you need to know about sodium hydroxide is that it is a deliquescent substance, meaning that it absorbs water, gradually, or absorbs moisture from the atmosphere gradually until it becomes a liquid. So, the answer to this question is B, water vapor. So option B. Question 12. The compound used as antifreeze in cars radiators in cold regions of the world is. Now the answer to this question is B, ethylene glycol. Now when this ethylene glycol mixes with water, it forms a solution that has a much lower freezing point than water. So even when the temperature drops significantly, the mixture will remain in the liquid state, preventing the coolant from solidifying and potentially damaging the engine. So the answer is option B, ethylene glycol. Now, question 13 here says, what are the laws that form the general gas equation? Now, we know that there are three laws that form the general gas equation, which are Boyle's law, Charles' law, and Gay-Lussac's law. But you see, I believe this is a trick question because someone might, get nervous and then end up picking B, which is Boyle's, Charles, and Graham's, but that is wrong. So since Gay-Lussac's law is missing, that means that the closest option will be A, which is Boyle's and Charles' law. Question 14. Chlorine, bromine, and iodine resemble each other in that all. The answer is A, dissolve in alkalis. Now let's disprove the rest. Option D says they are electron donors. This is not possible. They are actually electron acceptors. Why? They are in group 7 of the periodic table, meaning that they have seven atoms in their 7 electrons in their outer shell, and they need only one electron to be able to have a complete shell. So they are electron acceptors. Then option C says that reacts violently with hydrogen on heating, and they don't do this. Now option B says displace each other from solutions of their salts. I know that this is very wrong because displacement, of chemicals only happens based on reactivity. You see, so in this case, the answer is option A, dissolves in alkalis. Question 15. The method suitable for separating suspended particles is. Now, chromatography a is a mixture separation method where you identify components, you identify the various components of a mixture, as used in when you're trying to get the pigments in plants and in the leaf, in biology. So that rules it out. Now, distillation is removing the impurities and making, especially used in water, so that's where you hear about distilled water. That's water which has all its impurities removed. So that is wrong. And then we have decantation. Decantation is basically a trial and error process. So for example, now if you have um some little sand, for example, or some little impurities that are visible impurities, for example, in a liquid, so you drain it sort of slowly until those impurities are left, and then you are left with a somewhat pure substance left. So that's not the answer. The answer is actually centrifugation. And centrifugation involves rapidly rotating the sample to effectively separate the solids suspended within the liquid. So that means that our answer will be option C, centrifugation. Now, question 16. A hydrocarbon X has a molar mass of 26 and a carbon atom percentage of 92.3%. What is its molecular formula? So we're given the percentage of carbon to be 92.3%, and we know 100% is the whole. So that means that for hydrogen, we're told it's a hydrocarbon, meaning it contains hydrogen and carbon only. So that means that hydrogen occupies the remaining 7.7% of the molecule. Now, the next thing we're going to find is something called the empirical formula. And the empirical formula is simply the simplest whole number ratio of atoms present in a compound. So how we do that is that we divide the the percentage that that atom or that element is holding in the compound by its atomic number. The atomic number of carbon in this case is 12. So when we divide this, we get approximately 7.69. And then for hydrogen, we know that the atomic number is 1. So that will be 7.7. Now remember I said the empirical formula has to do with the ratio the whole number ratio of atoms present in the compound. Now 7.69 is basically 7.7. So now we know that the ratio is 1:1. That means that the empirical formula will be CH. That's the simplest formula for this compound. Now, to be able to get the molecular formula now, the question already told us that the molar mass is 26. So this empirical formula multiplied by, now this is the factor that gives us the actual molecular formula will be equals to 26. Now we know that the atomic number for carbon and hydrogen respectively will be 12 and 1. You add them together, you have 13n will be 26. That means that only n will be 2, meaning that the actual molecular formula of the compound is C2H2, which is option A. Question 17. Silica gel, when exposed to air, turns liquid. What kind of substance is this? This is what we call a deliquescent substance. Deliquescent substances are substances that absorb moisture, from the air, and then they turn to liquids. A hygroscopic substance, when it absorbs moisture, it becomes wet or sticky, But for efflorescent substances, these are substances that lose their water of crystallization. So that means our answer is option A, deliquescent. Question 18. In an equilibrium reaction, which of the following condition indicates that the maximum yield of the product will be obtained? And the answer to this question is A. The equilibrium constant is very large. And what this simply means is that the reactants in the reaction are appreciably converted to products. There is a very large, you can see that the product that is obtained is as much or very close to the reactants that were involved in the reaction. So the answer is A. Equilibrium constant is very large. Question 19. Under high pressure, real gases do not obey gas laws because their molecules, and we have four options here. The answer is actually B. The molecules have become less energetic. Now, at high pressure, the molecules are tightly packed together, because that the higher the pressure, the lower the volume. And so, since the volume is lower, it reduces the movement, and it also reduces the kinetic energy. So that's why they no longer behave like real gases, because they've lost that fluidity and the ability to move as freely as before, like real gases do. So the option or the answer is B, option B. Question 20. The salt responsible for temporary hardness is basically the salts that are responsible for temporary hardness are either carbonates or bicarbonates. So in this case, our answer is C, calcium bicarbonate. So you might see some questions instead of calcium, you might say something like magnesium bicarbonate. So you just know that carbonates and bicarbonates generally cause temporary hardness of water. And we know that temporary hardness of water can be simply removed by boiling. So that means that our answer is option C.